Okay, great. Thanks, Steve. Yeah, I'm Robbie Berglund. I'm a brand leader. Covered really two areas of interest within IBM. One has to do with environmental, everything environmental, weather, climate, anything severe with the environment affecting your operations, your assets. And the other is called Envizi, and that has to do with greenhouse gas accounting and carbon capture. And we're going to talk about both today. Where I'd like to start really is with the Environmental Intelligence Suite. So two topics. The first one is going to be weather and climate related. And I think most of us can agree, if you've been in the operational side of your business, that the environment, Mother Nature, severe weather is taking a toll on businesses. And this is a recent documented study that was done talking about $368 billion from US dollars of natural disasters just this past year. At the same time, we've just got changing conditions going on. Up 1.5 degrees doesn't sound like a whole lot, but it has a tremendous response. Everything from in the environment responds to this kind of warming, including winds and convective events, lightning, tropical, all that kind of stuff. At the same time, you look at the absolute dollar value assigned to climate change. This is from 21 to 26, is in the trillions now. And that you can see this is a drought emphasis here. And of course, wildfire, we had a little over 3.5 million total loss of hectares. This is like 10 soccer fields per minute in 2023. So there's a lot of events that are on the rise, and it makes it ripe for technology to try to address some of this. The truth is that there's 85% of organizations as well that have started to lean in towards sustainability investments. And think of environmental in this as well. And this is up from, I think about 75% the year before. And this is people that are having, to really, maybe for the first time for some of them, or for the first time in a real sense in a while, accessing all kinds of technology and data, putting it together to try to solve for, how are we going to respond? Artificial intelligence is a big piece of this as well. Obviously, that's a core focus within IBM. But organizations then need to decide, what vendor, what technologies, what front-end interfaces, or back-end, if we're going to do some of the work, can we leverage to try to deal with this problem? And IBM's environmental intelligence capabilities, organizations are going to gain climate, weather insights to anticipate disruptive environmental conditions, and then really get ahead of the risk. And this is really, in some senses about risk and then ultimately a behavior change. We're going to try to build an operation that is resilient, that can stand up to this, or at least handle it better. That's really kind of the name of the game, because there's a lot of pain points. And the pain points in dealing with technology and trying to solve for this problem are listed right here. One of them is just, can we even trust the data? Is it precise? Is it accurate? Is it compatible with what the kind of data sets that we're already working with? Our in-house, our customers that we're trying to serve, those data sets. Is it latent? Does it update very frequently, or is the information age out because conditions are changing fast, depending if you're talking about the strategic or the tactical side of changes in the environment? And then, do we have to handle the data? Can we even handle it? Sometimes this data is getting into well into the large terabytes in terms of size, and it's so complex, so heavy to move, we can't really do anything with it. So these are some of the pain points that we're trying to address. And IBM has a product, Environmental Intelligence. It's a modernized toolkit, APIs, SDKs that are part of this, that are going to deal with one of the big problems, the front end up here, is data preparation, just to get up to being able to do any kind of analytics as it matters to our organization. And then be able to extract that information and put it into our work environments, our work streams, so that, as I mentioned earlier, again, we do something different. The status quo, for many organizations just isn't going to work anymore. So we're going to work in different environments, and we're going to use this data to change our behavior, to change our operation. And I like to think of these in terms of historical data sets. If you're doing anything with modeling, history is critical. Real time or current conditions, what's happening right now, and then of course the long range, forecasted kind of information. And all the while, that's great information, but it has to be relevant. We have to be able to mix in our assets or our operation into those insights for this to make real sense. Those insights are going to make a lot more sense if we have the ability to, at our fingertips, mix in our assets, our operations with what's happening with the environment. Now, one of the areas I'm going to go within the environmental intelligence suite of product are these APIs that we've got. Some of them have to do with above ground biomass. I'm going to explain a little bit better about what that is. This really has to do with things that are changing on the land, mostly things that Mother Earth produces. That biology changing over time, and in what direction, what insights can we get from that? I'm going to talk a little bit about geospatial and other, you can see at the very end, weather data APIs. Geospatial, if you're not real familiar with this is the ability to layer insights. Think of like raster vector imagery, and to be able to gain insights from that. That is previously a relatively underexplored use of data and insights, and it's gaining quite a bit of steam now. We'll talk a little bit about our greenhouse gas capabilities and just weather data in particular. First thing I want to mention, just this geospatial API capability here. You see there's a lot of words on this chart, but this is an analytics engine for being able to get to these different queries or questions that we want to ask. We want to be able to inquire, what do these different layers have in common? If I wanted to stack up 10 different layers, it could be my customer assets. It could be information about how my customers have responded with sales. It could be, of course, environmental impacts. Let me just throw out flood, wildfire, some of the real common ones. But if I stack them all together, and at any latitude, longitude, if I could normalize those data sets, tie them together so that if I wanted to reach down into the 10 or 15 different layers, I could pull out this core that has something in common across all of those. And there's a lot of different use cases that you can do with that. But to be able to do that, you are combining layers that have completely different, spatial attributes. They're completely different time sets. Some of them aren't even complete. They're spotty in nature and need to be filled in or need to be cleaned. There are temporal time steps that differ from each other. And that's sort of the name of the game, is to be able to put those all together and get to insights or commonalities quickly so that you can apply what you've learned to your operation.
Hey, Robbie, so
yeah.
quick question. So can IBM help with changes in my company's operational exposure after a storm comes through?
Yeah, in fact, we're going to talk just a little bit about that in a second. And where you're going to hear me go is an emphasis on both let's say before the storm. So right before the storm, here's what we're going to predict is going to happen to your operation. And then right afterwards, which in this probably more closely aligned with what I'm speaking about right now, which is changes to the land. And, just take a storm, for example. How much vegetation did it knock down and where? Was it on top of or was it near my assets? Those are great insights that you'd be able to get from this. And again, you need to get to those timely. And you see a little bit of some of the others descriptors here. Wildfire, you could say that's a predictive. It's also a real-time or an after to your question there, Steve. Wildfire is a big one. That's a great and very common use case for these capabilities, but there's others too. Agriculture, anything changing with terrain and topography, planning, for example, for our assets. Do we make a gigantic capital investment? Let me just give you this. This might sound random, but it has come up. On the side of a river, if the river is going to erode or has been eroding over time, right? You would not want to deal with those problems and put your assets at risk. So these are the kind of insights can tell you, yeah, that you've got real river erosion or erosion along the coast, in these places. Vegetation, that's one I am going to pull out specifically in just a little bit. Vegetation changes and how we respond to those, because they tend to mix badly with our assets and our operation. Now, one of them I mentioned earlier, I said that I was going to go into this, is above ground biomass. Now, this is interesting, right? We're really looking from space. In this case, we're using different imaging sources. Certainly one of those is satellite, to determine, hey, across a gigantic area, so scale, really, really large scale. You could do this across a country, multi-country. You could do it at a small area too. But to be able to assess what is the forestry that is there, or how much has been deforested, how much has changed. That'll tell you a lot about things that are real common, like wildfire. It'll tell you about some things that are maybe more abstract, like how much carbon did we just remove when that forest went down? We have a way to calculate. That's called carbon sequestration. In other words, how much carbon is stored in any amount of vegetation. And that is a capability that's part of the environmental intelligence suite. In fact, here's some use cases that have to do with that. Let's monitor forestation, deforestation, impact of the wildfire, how much carbon is captured in the area that we have management for, or perhaps that we own, how much is captured in an area that we want to purchase. Perhaps we're using that as offsets when we ultimately come to calculating our own greenhouse gases. And so as the carbon market has continued to heat up, understanding how to get a hold of our total carbon footprint, this is becoming increasingly important. Now, what I want to do is shift from bigger, broader cases to that, to some very near and dear cases, like just weather. And weather data is something that we excel at. And weather data, as you can see, I won't go through all of these. There's a lot of different types. You can see my buckets that I mentioned earlier: historical, real-time current, or forecast. There's point data. There's imaging style data. So we're talking about Tyler, rasterized, type data there. From just about every kind of weather phenomenon that could come your way. And people that use this, they're used to dealing with data, they're used to dealing with APIs, they're wanting to bring data into their operation, usually embedded in something that is going to drive real insight. Now, when it comes to the imagery side, so again, back to things that are spatial in nature, GIS, if you're used to hearing that term, then what we're talking about is having a developer council. So that is something that IBM has invested in more recently, to be able to move all this information around. Now, sometimes clients would say, look, we can do this ourselves. And we say, great, have access to the data and do it. This developer council is just one step ahead of that, where it's, okay, we're going to give you a tool set and let you explore the data yourself and start to make the queries and get into execution yourself. And you need a good front end that is going to help you do that, because there's a tremendous data catalog that's available here. And you want to be able to explore the data sets, geospatial data sets, historical data sets at different locations and timeframes. As I mentioned, stacking these things together sounds easy, but without the right tool set to move really heavyweight items that are completely different in every kind of structure, temporal nature, all that, it gets to be difficult. And so this developer council is meant to be there to make that easy. Okay, now what I want to do is focus on, from the environmental intelligence side, two applications that are near and dear to me, that I really love. I'm going to focus here on vegetation management and something called outage prediction. Now, vegetation management is something that is meant to address, just like it sounds, the interactive nature of vegetation as it has to do with assets. Now, we can pick on a lot of different ones here. This tree on the right is mixing with power lines. It could be mixing with roads. It could be mixing with rail. It could be mixing with insured assets like houses or commercial properties. The risk of the trees falling on houses. So there's a lot of different ways that vegetation mixes poorly with an operation and with assets. So this is an activity and a technology that's going to address activities done way before an environmental event, say a storm, ever shows up. But on the left, we'll talk about it right after, is something called outage prediction. So no matter how good or bad your organization has done with managing vegetation away from assets and away from operations, at some point Mother Nature is going to show up and is going to put your assets and your operation to the test. And that's sort of what you see on the left here. We'll talk about both. As far as strategies go to handle assets, I really like this chart because I've seen this play out with customers time and time again. And depending on what kind of an operation you are, you may be down here on the bottom end, which is reactive. Okay, we'll just react, with how our assets have held up against this latest storm when it happens. Or maybe you've got somebody there that's been there 40 years that knows everything about your operation, everything about the assets, kind of knows about weather events, and maybe uses a mobile app or something and tries to say, okay, I think this is what's going to happen with this oncoming storm. Okay, but that's not a great strategy. To me, it's even one less than just let the things just run to failure. Even if the assets are being very much impacted by the environment. Just slightly ahead of that, I'll pick on an industry, the utility industry. Very common to do calendar-based. We'll just divide up our assets or divide up our territory, which is often very large, and deal with it once every 4 or 5 years. Okay, we'll call that calendar-based or cycle-based.
Or a calendar-based like hurricane season.
That too, seasonality. Right. And just deal with it if the storm happens to come our way, right? It's a risky way to deal with things. Kind of interesting I'm using the word risk. As you move further up the maturity curve, you start to get into things like condition-based, like, okay, we understand from a data-driven perspective, not emotional, not the guy named Bob that lives down the hall and he's been here 40 years, but true data-driven insights that tell us how our assets are going to hold up under the current conditions that are coming our way. You start to get predictive that way. You can even at the top of the curve start to become financially optimized. Well, if we make choice A, I think it's going to deal with this environmental impact that's happening or about to happen, but option B gets us 80% of the way and it's half the cost, right? Those kind of things start to come to bear, okay? So again, I'm going to go into a very specific example now. And what I would say is for any technology that's going to address how the environment is interacting and playing, in this case, we'll just say vegetation, it needs to be able to handle scale. Okay, this is not like a single farm field that we're talking about or that we're interested in. This is usually thousands, if not hundreds of thousands of acres or linear miles of concern, of area of concern. And I've talked to many, many operations managers that are really handle a very vast, large area that are utterly perplexed on any given day what is actually happening with the environment, with vegetation in their operation. It's so big, so vast. So the technology has to handle scale. It needs to handle frequency. Relevancy is a good word. Time to insight might be the best way to describe this. If a technology company can give insights, it needs to be fast because conditions are changing. They're changing fast. So you don't want the information to age out. If money were no object, well, why would we even adopt technology at all? Let's just let's hire 500 or 1,000 people, put them in the field, and they can tell us what's happening on any given day. But that's not cost efficient, and they can't scale. But cost is an issue, and then precision. Whatever we're doing, is the information precise enough so that we can make intelligent decisions and usually put a lot of money on the line? Let's talk about this specific example. Here's an asset. It happens to be a power pole. You can see the kind of horizontal slice against this. It could be a house, it could be a business, it could be a roadway, it could be rail. There's a lot of things that it could be. It could be a renewables farm. But you've got vegetation coming within a certain distance of the operation or the asset, and that's a bad thing, right? We generally speaking want that to be removed, and that's what organizations spend millions of dollars to do, whether they do it by calendar, talked about calendar-based, or they do it conditioned, meaning on any given day, they could come in, sit down at their desktop, open up the work screen and say, okay, today, this week, this month, we're going to address this area over here because it's got the closest encroachment and it's causing us, we can see it in our data, it's causing us the most problems. So how do you get an assessment like this? I mean, how would you ever know, I don't know, let's say across 100,000 miles, what actually is happening on any given day, week, or month? Now, one of the ways that we do this, remember my 4 pillars: scale, how long does it take, time to insight, is it cost effective, and is it precise? One of the ways that we do this is LiDAR. Okay, some of you know what LiDAR is, some don't. Think about it, it's a laser pulse that comes out of a device. It could be on a vest, people walk around, it could be truck or car mounted. There's even iPhones these days that have LiDAR built into the camera if you want to pay the extra for it. And in this case, to get scale, we have it mounted on an aircraft that is very high, very fast. There's forms of it that are mounted on satellites as well. And ultimately, what you want to get is something that looks like the left. Okay, whatever the asset is, insured houses, power lines, whatever, you want to see how close or how dangerous that vegetation is, i.e. the risk to your operation, because then it tells you what to do. Would I direct $1 million at my assets if there were no red splotches here? The red splotches are vegetation that's causing a risk to my asset. Would I want to spend a lot of money on an area that has no signal, no red flag here? Absolutely not. But that's what's happening today, is many are spending money on areas that aren't going to matter at the end of the day, and they're missing the areas that do. And those areas that do matter, they're causing problems. So what can we do? Across a very large area, whatever it is, we can do a risk scoring based on these insights that we're gaining remotely. We'll call that remote sensing. In this case, I've got a vegetation score, just like in school. A, B, C, D. A is good. A would be something like, don't spend any money, no time, and no people to this area. D, like in school, would be bad. Like, go get your people there now, because the next weather event is going to seriously cause a problem in this D area. So I have customers that have segmented their entire area, whatever the area of interest is, their operation, whatever assets they've got in a field, and IBM has scored their assets relative to weather, to environment, to vegetation, and they'll just filter on every D score in the entire territory and say, okay, this is where we'll put our money, on the D scores. And the results are tremendous. And they're seeing operational efficiency, they're seeing reduced budgets, they're seeing improvements in resiliency and reliability. Those are all really great things. Now, no matter what happens, I mentioned this earlier, whether you do good or bad with that maturity curve I showed, maintenance strategies in advance based on conditions or risk or financial optimization, no matter how good or bad you've done, here comes the weather. This is the problem. And the weather is going to do something. It is going to put your strategy, it's going to put your assets to the test. Now, look at this little graphic that we've got here on the right of this chart. Again, the guy that's been there or the gal that's been there 30, 40 years, right? And they're getting some information. Maybe it's on a mobile app. They've certainly been around long enough to see how the assets and the operation holds up. But what do you do with this? How do you respond to snow showers? How do you respond to blustery winds? Looks like there's going to be lightning and thunder. How do you deal with that? Data. Data is what you need. A data-driven approach that takes out emotion. It takes out guesswork. Because if I were to tell you, okay, here is your asset in the middle of a field, and there happens to be 12% soil moisture. You've got a wind coming at you now from 45 miles per hour from the southeast, gusting to 62. You've got a lightning threat at 17% chance. You start to get so many variables combined. The human brain, even for sophisticated experts in this, they can't keep it all together, right? And that's where you need a technology, a data-driven approach. Ours is called outage prediction. There's a lot of things that could be out of power, out of gas, out of sales, but an outage-driven approach that has to do with the weather. So this is a trending, a forecasting, not of the weather per se, although the weather, the climate, the environment, vegetation included is all part of it. But how many outages am I going to have of whatever variety in the next 7 days, for example? Where are they? When are they going to happen? And then what this solution is geared towards is recommending a response. And you see at the bottom of this chart that I've got here, there's a level. This is very common, a do nothing, a level 1, 2, 3, 4, 5. These are all customized. This is a model that is custom to each customer and built up so that it not only tells you where your outages are going to happen, but it tells you what kind of response makes sense. Truck rolls, for example, for restoration of power, restoration of gas, restoration of the operation. Where and how many truck rolls should I have? Because that, on any given day, a truck roll is in the millions. It can be. I mean, this can be extremely expensive kind of decision to make. Now, if you knew where this was going to happen in advance, you position your trucks there. You position your people with the right equipment at the right time. That's what the nature of this technology and the solution is about. Now, that's all what I'll call tactical. What's about to happen right now in the very short term. But what about if you're a company that says, yeah, that's not really our thing. Our thing is more that we make gigantic capital investments over really long periods, right? Now you've got something to do with risk to that investment. Enter climate risk. This has to do, in climate and weather, these terms get interchanged sometimes in poor ways. Think of weather as the short term. Let's just say today, tomorrow, this week, next couple weeks, this next month, the next couple months. Okay, that's weather insights. Climate is more like what's going to happen in the next years, next year, 10 years, 50 years down the road. Why would anybody care about that? Well, if you're making a major construction or asset purchase decision, is this asset that you're purchasing or that you're funding or that you're getting ready to just make really large maintenance decisions on for the long haul, how is it going to respond to the climate? Everything from drought to wildfire to flood to storm surge to recurring high wind areas. These are all things that impact and damage assets. And you want an area and a way to understand if climate is how it's gonna mix and match with this. You even see one bullet here, the value statement here. This is about physical risk. It's also about this information for how the climate's going to impact my assets is required more and more in greenhouse gas reporting, ESG reporting. Which brings me to my next topic, ESG. Before I do that, I want to stop and see if there's any other questions that have to do with environmental intelligence, with weather and with climate. Is there anything else out there right now before we move into ESG and greenhouse gas management reporting?
I'm not seeing any questions, but do you have an example of if IBM is using some of these tools in-house?
Yeah, absolutely. In fact, the one, so we're shifting gears to talk about Envizi and ESG data management. Envizi has become the de facto, taken over the technology for all sustainability reporting for IBM. So IBM is, for years and years, has been a tremendous steward in the environment. Even before it ever was called sustainability, IBM was reporting and disclosing on how its operation was contributing to the environment. And in this case, I'm talking about things like greenhouse gases. So that question actually tees up this topic, Envizi. And just in case Nobody knows what ESG is. And again, this is something that IBM first, after a while, IBM got to the point where it's like, we can't, as good a job we're doing, keep up with this. It is a tremendous amount of data coming from all over the world, extracting information from all of our assets about how they produce greenhouse gases and carbon, and we want to be good stewards, but this is getting to be cumbersome and tremendous. So they ran an RFP with 30, 40 vendors, selected this technology called Envizi, and then ultimately acquired it and are offering it to the market now. But ESG, just in case we don't have a common understanding here, I think most people know what this is now. I mean, it's been all over the news, right? E is environmental, okay, and this usually has to do with your carbon pollution, your greenhouse gases. It's the top way right now that people are interacting with these three letters. But there's also social, right? How our company impacts people in the society. You got labor practices, diversity, human rights, and then governance. Just how our company is run, ESG. And as IBM discovered, you need a way to assess this technology and to be able to get your hands around what, as I mentioned earlier, becomes a very big data management problem. And ESG, right now, many are reporting their carbon footprint, we'll call it, voluntarily. But what is on the increase is we'll call them mandates, which is if you're going to do business in this area of the country or this area of the world, you will report. And can that report stand up to scrutiny, an audit, for example? So Envizi helps companies get ready, get that data pulled together so that it's financial grade. Yes, it could stand up under audit. It helps the companies get ready to do reporting and disclosure, whether it be just internal or on our website. Most companies these days, if you go and Google search their web, you're going to see if they've got a sustainability report or not pretty quickly. And there's not too many companies that are going to be left out of that much longer. And then ultimately, if we don't do anything else except identify the data, pull it together and calculate our carbon footprint, report on it, if we didn't do anything else, we just have a piece of paper. Okay? Because the next step after that is behavior change. Let's actually have some goals to reduce our carbon and do something about it. It looks a little bit like this. Put a data foundation in place, one that can stand up under audit, get to reporting, whether it be internal on our website, or we're going to meet these mandates in the areas that we want to be able to do business. We don't want to be fined for that. One that I didn't mention yet, engage your stakeholders, right? I think that the future is very near where a company is so risk averse to its investors, and then one step beyond that, the public, that does not want to engage this company because they're not taking pollution and sustainability very seriously, right? There's not many companies left that aren't ready to engage and show their stakeholders, whether it's public or investors, that we got a hold of this. We've got a calculation made on our impact on the environment, and then the right-hand side, we're doing something about it. It's not just a piece of paper. We are moving towards decarbonization. Okay, we're reducing our pollution. Okay, to be able to do that and to stand up under scrutiny, it takes a lot. It takes technology. And IBM, again, adopted this technology. I would say uses most of the developments that we keep pouring into this solution. And I'm going to talk about these in terms of these columns. You can see there's, let's say, 4 columns here. First is just emissions management. Can we get a hold of the data? I won't go into it all if you're not used to dealing with the scope 1, 2. That has more to do with our internal operation, our internal consumption, and the pollution that causes. Or there's scope 3, which has a lot more to do with, well, either our assets that we're financing or our vendor supply chain, for example, scope 3 outside of our organization. Okay, and then the ability to set targets and to track those emissions. Then there's reporting, a set of tools that had to do with, okay, we've got our data together. I think it's auditable. It's ready to stand up under scrutiny. Now we want to report on it. Well, we need help. Companies have been doing this with massive spreadsheets for quite a while, introducing error, a ton of time sucked down, to try to get that data pulled together. It's not automated, but we want to be able to have a set of tools that are going to help us then take the data from the first column and move it into a report. And then, like I said just a second ago, all right, once we have a report, what are we going to do about it? Will we be the company that does nothing about it? Or are we going to be the company that starts to move towards some goals that actually show a trending or a reduction of our pollution, of our carbon out there? And so there's a set of tools with that. And then more recently, we're calling these advanced modules. I won't get into all of them. IBM is great because it keeps embracing the latest ones that we put out and helping us test and vet. There's a new one here for supply chain, which is absolutely outstanding. I think it's world-class. Supply chain is extremely difficult. If you're in supply chain at all, you know that there's a lot of data, a lot of movement, a lot of vendors that are going on there. And you know, this is all great technology, but the world is moving towards making things easier. What about AI? So one of the areas, not the only one, but one that I want to say is we take a client's data, we'll call it spend data, how much they're spending on services, goods and services, capital goods. Every expenditure that a company has a carbon footprint with it. And we take AI, Watson X, and we classify that data so that you can quickly convert it amongst a massive, massive library of coefficients or conversion. We call them emission factors, because every little expenditure has a different factor. If you want to be auditable and hold up under scrutiny, you need to do this. And then to be able to calculate that and say, this is the tonnage of carbon that I've got, of greenhouse gases that I've got. This used to be a manual process of converting that from a client's data, going to a library and selecting the right factor, and then converting it to greenhouse gases. Watson AI helps us do that automated now. The infrastructure looks like this. This is Envizi on the left-hand side. A lot of areas, a lot of ways that data is coming in. And this is one thing that has absolutely perplexed departments that have been given this onerous task of, hey, go ahead and tell us what our carbon footprint is. You, sustainability manager, go ahead, start reaching out to all the different departments, pulling in data from our ERP systems, our HR systems, and calculate this. A lot of different ways to get at that data. Is it manual? Is it automated? Is it, how do you get it? But bring it in this case, to Envizi. Now, once it's in Envizi, you're going to be able to calculate tremendous insights. Power BI is embedded in Envizi, so there's a lot of, we call them power reports, that are tremendous reporting tools that have everything to show, yes, we're on track. No, we're not. We're on track, but there's one department over here in some area of the country that is underperforming. I can see all their metrics. I can reach out to them and see what's going on. Maybe it's a glitch. Maybe it's something in their reporting. Maybe they really are not taking this seriously. And then once all that data is crunched and calculated, to the right, move it to the right, customizable reporting, whether it be, again, voluntary, something we produce on our website. It could be something that meets a mandate. You can see some of those reporting frameworks at the bottom. If you are in California and you are higher than $1 billion per year in revenue, you will report on this, or else you're not going to do business in California, according to the state of California. Same thing overseas in Europe. They call it CSRD as a report. If you're a US-based company, multinational, doing business, you're going to have to report to that framework or that template over in Europe. So Envizi is really meant to speed up, make auditable, something that improves your relations with your stakeholders, whether they be investors or they be the public, keeps you out of trouble if you are doing business in an area of the world that requires a mandate, so that your risk is down, your compliance is up, and you're not spending a lot of onerous time on loads and loads of spreadsheets with tons and tons of error and people running all over the place to get this data together. That's a big Envizi value add, and one reason that IBM has embraced this and really is just not backing off of that, continue to accelerate getting carbon neutral. That's a very common buzzword these days in this technology space. Is okay, we got our data together. We have reported on it. And now our big goal is to get carbon neutral to where, we could report with a straight face and honesty under scrutiny that we're at net zero. Now, companies that make that claim really have to be sure that they're ready to make the claim. There are people getting hauled into court for making that claim and then finding out, well, they're really not. That the public won't stand up for that.
And Robbie, this is big, right? I mean, in Europe, they're all well down the path on this, right? So over here in North America, this is next. This is coming. So we need to be aware.
That's right. Yeah, I hate the fact, but you've nailed it, Steve. I mean, the U.S. in particular is a bit behind, on things like taking this seriously, but they've ramped up very quickly. Europe is definitely ahead. That's why you've got probably the most prolific, again, we'll call it mandate over there to report on this stuff if you're going to be a multinational company operating in Europe. So they're well down the road. We're learning a lot of lessons from them here in the U.S., and the U.S. is ramping up and it's coming fast. So that is the end of my presentation. And I want to see if there's any other questions or anything else that we need to address for today. Environmental, climate, ESG, environmental social governance. Those were the topics today and how a company interacts with those.
Yeah, folks too, please, while we've got Robbie here live, let's put some questions in chat. Right now, not seeing any questions, Robbie.
Okay. Well, we've done a pretty good job so far. That's great. I don't have anything else then. I will just say this, of all the things that I've gotten to do in my career, I've been in weather and climate for about 25 years. And, I showed this opener slide here. That's actually me. It's kind of a corny looking picture, standing in front of a field of something. Now, that's not a farm. This is an operation. It happened to be a gigantic company in Texas that was trying to figure out, areas of risk in its territory and out in the field. I'm standing in front of something called giant reed. Giant reed is an invasive species that made its way into Texas. It gets to be up about 20 feet tall. It's very flammable. You can't have this in or around your assets. And this swath that I'm standing in front of, I wish we would have taken an above picture. It's about a mile long. The funny thing is the customer didn't even know it was there, right? Until we remote sensed it, put it into digits, digitized it, showed it on an application, said, hey, there's something here. We went out to the field. This is what this is. Probably the highlight of my career is putting on boots, standing in mud, and going out and saying, wow, let's take a picture of this. We found this. And what does the customer got to do with it? They got to maintain it. They need to get it out of there. Okay. Those are the kind of fun things that this leads to and lends to.
Yep. Not seeing any questions. So I'm going to say that I think that's going to be a wrap for this second session then. So love to talk to you guys more during office hours later today, or, Tech Exchange is going to be in Orlando, Florida, October 6th to the 9th. Please join the Tech Exchange community to get the latest updates and events that we actually have coming on. Please also take the survey that we've got at the end of this live session. You can always go back to these sessions and replay them and hear things that you might didn't catch the first time. But in the meantime, I'd say go grab a lunch, grab a snack. Our next session is going to be at 12:20. So I appreciate it. Thank you, Robbie.
Thanks, everybody. Have a great day.